Okay, everyone, let's get ready for Regents Review number 4. The first question, we're looking at undefined functions. Now we know that fractions are undefined when the denominator is equal to 0. So we're going to have to find the values of x that would make the denominator equal to 0. So let's take the denominator x squared plus 2x minus 8 and set it equal to 0. Okay, now this is a quadratic. The way we solve this equation is by factoring. Okay, so let's factor, and it's a trinomial, so let's go ahead and make our two sets of parentheses and find the factors that will work. So the factors of 8 that are going to give us a 2 would be 4 and 2. And to get a positive 2, we would need a positive 4 and a negative 2. Now we're going to go ahead and set each of the factors equal to 0 and solve. So x plus 4 equals 0 and x minus 2 equals 0. That means that x is going to be equal to negative 4 and x is going to be equal to 2. Those are the two values that would make this function undefined. Okay, so let's go on to question number 2. Now we're finding the inverse of a function. What does an inverse mean? You know, we need to swap the x and the y. So the first thing we're going to do is we're going to start by setting the function equal to y so then we can make the swap. So y equals x plus 1 over x minus 2. Now we can go ahead and make the swap. X equals y plus 1 over y minus 2. Now we have to solve for y. So what we're going to do is we're going to multiply both sides of the equation by the denominator to get rid of the denominator. Excuse my penmanship, I'm getting used to writing with this new fancy pen. Okay, so remember we need to distribute. So I have xy minus 2x is equal to y plus 1. Remember, these cancel out. Now, whenever I'm solving for a variable, I need everything with that variable, all the terms with the variable on one side and everything else on the other side. So I'm going to go ahead and move the y to the other side, and I'm also going to move the 2x onto the other side so I can separate the y's from everything else. Now I have xy minus y is equal to 2x plus 1. Now the only way to separate those y's is by factoring again, and this time we're going to use the greatest common factor. All right, I'm going to bring this over here now so I have a little bit more room. So I'm going to factor out the y and I get x minus 1 is equal to 2x plus 1. Now I can divide both sides by x minus 1. And I have my inverse. So my inverse is equal to 2x plus 1 over x minus 1. All right, and that's how you find the inverse of a function. Now let's move on to question number 3. Question number 3 is a little bit easier. You're just writing these two radicals multiplied together with a rational exponent. Now remember, rational means fraction. I'm looking for a fractional exponent. So if I were to take the cubed root of x and I wanted to change it to a rational exponent, remember there's a little 1 here. Power over root says I'm going to move that 3 over. So that's going to be equal to x to the 1/3. Now, if I do the same thing with the square root of x, remember there's a 2 here and a 1 here. That 2 is going to go over power over root again, and I'm going to get x to the 1/2. Now, remember I'm multiplying these together. So I'm going to take x to the 1/3 and multiply it by x to the 1/2. And remember, when we multiply, we add exponents. Now, you can do this on your calculator, or you have to get common denominators before you add those exponents. You end up with x to the 5/6, and that is your answer. Okay, so the cubed root of x times the square root of x with a rational exponent is x to the 5/6. Now we're going to go on to question number 4. Now question number 4 has, first of all, a typo in it. That 6 should not be there. Okay. Secondly, there's lots of different ways of doing this. All right. I'm going to start by simplifying what's inside the parentheses. So I have m squared divided by m to the 1/3. Now, you know when you divide, you subtract exponents. So 2 minus 1/3, and again, you can do this in your calculator, or you can get common denominators, but you get m to the 5/3. So remember, though, that m to the 5/3 is still being brought to the negative 1/2 power. Power to a power, you multiply. So now I have m to the negative 5/6. Now that negative exponent isn't doing me much good. That's going to be 1 over m to the positive 5/6. Now, if you look at your choices, they're all in radical form. So I'm going to change that to a radical. Remember, power over root, the 6 becomes the root. And I still have it to the 5th power, and that's all over 1, which makes option 2 my answer. On to the last question. Okay, so number 5 has a combination of a couple of different things. First, it has Pedro, which has an ant farm, and he starts with 100 ants, and it's growing exponentially. So remember, exponential functions are in the form of y equals ab to the x power. And remember that b value, since it's increasing, is going to be 1 plus the rate of 15%. So we're going to start with Pedro. P of x is going to be equal to 100, which is the starting amount, and then 1 plus the 0.15, because we have to change that percent to a rate as a decimal, and that's Pedro. Now, Bobby's a little bit different. He's starting with 350 ants, and it's decreasing by 5 ants per month. That's linear. So Bobby is starting with 350, and it's decreasing by 5 per month. Now, X is representing months, and Y is representing the number of ants. Okay, so when we're solving this graphically, we want to set our window up right. So since months, I really don't know exactly what it's going to be. Well, I kind of do because I did this question already, but you won't know when you're trying to set up your window. I would start with 10 and then increase or decrease if it's necessary. I do know that the number of ants has to go up to at least 350 because that's what Bobby started with when it started to decrease. So I'm going to put in my calculator y1 equals 100 times 1.15 raised to the x power. And I'm going to put into y2 350 minus 5x. So I'm going to find when I graph it after changing my window. Since Pedro is starting at 100 and growing exponentially, it's going to look something like that. Bobby, on the other hand, is starting at 350, and well, oops, that didn't work. Bobby is going down linearly, so it's a straight line. So this is Bobby's function. We're looking for this point of intersection. Okay, so that point of intersection is going to be at x is equal to 8.1 rounded to the nearest tenth of a month. So that's our answer, 8.1. Remember, in order to do this, you need to hit second, trace, intersect, enter, 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 and you get the intersection point of those two. My graph is a little off in my drawing, but the answer is 8.1. I hope you found this helpful. Make sure you study for this Regents Review number 4.